Bismillahirrahmanirrahim. This is Dr. Muhammad Asif Iqbal. Our today's lecture is about functional groups in organic chemistry. Let's we start our today's lecture. Hydrocarbons. The compounds of carbon and hydrogen are called hydrocarbons. In the hydrocarbons, we have the example of alkanes, alkenes, alkynes, and arenes. What's the difference between alkanes, alkenes, and alkynes? If a single covalent bond is present between carbon to carbon atom, the compounds are called alkanes, and the name of the compounds ends at ane. If a double covalent bond is present between carbon to carbon atom, the organic compounds are called alkenes, and the name of the compound ends at ene. For example, here we have the example of ethene. Similarly, if a compound contains carbon to carbon atom, a triple covalent bond is present, they are called alkynes. Here we have the example of ethyne, and the name of the compound ends at yne. Likewise, we have another compounds, arenes. Here we have carbon to carbon atoms, but this is not an open chain compound. This is a closed chain compound. And here we have the example of benzene, and the name of the compound ends at ene. Now we move to another class of organic compounds. They're called halogen containing compounds. If we remove the hydrogen of the alkane by a halogen group, you can see here, the name of the compound is called alkyl halides. For example, we have here ethyl chloride. Simply, we replace one of the hydrogen by one halogen element. For instance, here by chloride, the name of the compound is called ethyl chloride. Just like arenes, here we have the closed chain. Simply, we have seen here the name of the compound is called benzene. 6 carbon atoms in a closed chain with alternative double covalent bond in the compound. The name is called benzene. If we simply remove one of the hydrogen from here with one chloride, the name of the compound is called chlorobenzene. Now we have oxygen containing compounds. In all the compounds like alcohol, phenol, ether, aldehyde, ketone, carboxylic acid, all the 6 classes, they have oxygen in them. If we see here, with the alkyl group, we have the OH group. So this is called alcohol. And the name of the compound ends at OL. For example, if we see here, if we have one carbon atom in the compound, this is called methyl alcohol. And if we see here, this is a cyclic compound, and if we remove one of the hydrogen with OH, this is called phenol. And the third one is ether. If we see here, what is the difference between alcohol and ether? In the alcohol, we see here on one side is alkyl group, and the other side simply we have OH. What we did simply, we have removed this hydrogen by an alkyl group. So this is called ether. Here we have two carbon if we see here, this one is a methyl group. This one is also a methyl group. And in between two methyl groups, we have the oxygen. So this is called ether. Here we have two carbon atoms on the left side of the oxygen, and on the right side, we also have the alkyl group with two carbon atoms. One is called methyl, and the second, if any compound we have two carbon atoms, then it is called ethyl. So that's why the name of the compound is diethyl ether. The next one is aldehyde. What is the difference between an aldehyde and ketone? The difference between aldehyde and ketone is this functional group CHO always comes at the end. But if we see here in the ketone, this is CO, it can come at the end, it can come in the middle or any place. Suppose, see here, this one is the functional group for aldehyde. So we can say this group is aldehyde. And if we want to name this compound, very simple. This is, here we have two carbon atoms. Two carbon atoms means ethane. And if we remove E of the ethane with Al, then it is called aldehyde. The name of the compound is ethanol. So it means from ethane, if we remove E with Al, the name of the compound is ethanol. This is IUPAC name, but in the organic chemistry, we have some common name. So you can say the common name of this compound is acetaldehyde. The next one is ketones. In the ketone, very simple rule. First, we have to identify this one is our functional group. So from the functional group, we identify the given compound is ketone. Now we want to give the name of the compound. In the, here we see there are three carbon atoms. For three carbon atoms means propane. And if we replace the last E with ONE, then we can form the IUPAC name of the ketone. So you can say if we replace E with ONE, then it is called ketone, means three carbon atoms, propane, then it forms propanone. But we have, as I have told you already, the functional group can come at any place. So it means we have to mention the position of the functional group when we want to write the name of the compound. So if we see here, The functional group is present at position number 2. 1, 2, 3. If we count from here, 1, 2, 3. So from the left side or on the right side, you can start your numbering. So the name of the compound is true propanone. The next one is carboxylic acid. If you see the basic difference between the aldehyde and the carboxylic acid, here we have the same COH, but here we have COOH. Likewise, the aldehyde, the functional group always comes at the end. So if we want to name of this compound, first we will count the number of carbon atoms, 1 and 2. From 2 ethane, 2. So if we replace E of the alkane with ic acid, oic acid, just like I have shown it here, so the name of the compounds becomes ethanoic acid. Now we move to the next one. Here we have esters and amides. Here you can see, just we can compare the aldehyde and carboxylic acid. Similarly, we can say here, what is the difference between ketone and ester is simply here we have one more oxygen atom. See here, we can write the name like see here, this is CH3 is methyl and 1 and 2 carbon ethanoate, methyl ethanoate. Amides, when we have this amine group in a compound, so we can say this is amide. Nitrogen containing compounds. Here we have amine, nitriles and nitro compounds. Here you can see we have 3 types of amines: primary amine, secondary amine and tertiary amine. How we, for simple understanding, if we see this one is your nitrogen, this is hydrogen, this is hydrogen, this is hydrogen, this is called ammonia. And if we replace one of the hydrogen by an alkyl group, so this is called primary amine. And if this is nitrogen, now it has one alkyl group. If we replace the second one hydrogen by an alkyl group, so this is called secondary amine. And likewise, if we remove the third one, so this is called tertiary amine. Here we have 2 carbon atoms, so this is called ethyl amine. Acetonitrile, and simply here we have benzene. If we replace the hydrogen with NO2 group, so this is called nitrobenzene. Now, dear students, we have a short quiz for the better understanding of the today's lecture. You have to guess this compound. Yes, in this compound, you will see carbon, hydrogen, hydrocarbon. So it may be alkane, alkene, or alkyne. So I'm giving you a clue. All carbon to carbon, we have single covalent bond. So the answer is alkane. Now we have this compound. Here you can see the methyl group, and here carbon to oxygen, here the oxygen. So I have given you the clue. So the right answer is esters. Now our next example is this one. nitrogen, 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 hydrogen, hydrogen, and this one is alkyl group. So this is amine, primary amine. So please guess the fourth example. Yes, methyl group, and this one ketone. Next example, this one is alkyl group, and this is OH. Alcohol. This functional group at the end, yes, aldehyde. Next example, please guess. Yes, carbon to carbon triple covalent bond. Yes, this one is alkyne. Next example, arenes. COOH. Carboxylic acid. Next example. Yes, carbon to carbon, double covalent bond, alkene. Please guess this one. Alkyl halide. Now we move to saturated and unsaturated hydrocarbons. If a single covalent bond is present between carbon to carbon, this is called saturated, and if a double covalent bond is present, then it is called unsaturated hydrocarbon, whether a double or a triple covalent bond. I have told you, if the hydrocarbon in which carbon to carbon atoms are fully satisfied by the hydrogen atoms, then they are called saturated hydrocarbons. The example is methane, ethane, propane. Now we move to the unsaturated hydrocarbons. If in the hydrocarbons, in between carbon to carbon, there is a double covalent bond or a triple covalent bond, then the compound is called unsaturated hydrocarbon. For example, you can see here double covalent bond between carbon to carbon atom, and the number of carbon atoms are 2, so it is called ethene, propene. Here you will see the examples of alkenes, and here you can see the examples of alkynes. Alkenes and alkynes both belong to unsaturated hydrocarbons. Here a double covalent bond, and here a triple covalent bond. Here we have some common differences between saturated hydrocarbons and unsaturated hydrocarbons. If a single covalent bond is present, then it is called a saturated hydrocarbon, and if a double covalent bond or a triple covalent bond is present, then we can classify them as unsaturated hydrocarbons. In the saturated hydrocarbons, they have more hydrogen atoms in them, and if we see in the unsaturated hydrocarbons, they have lesser hydrogen atoms as compared to the saturated hydrocarbon. Saturated hydrocarbons are less reactive in nature, and they are more reactive in nature. Saturated hydrocarbons shows substitution reaction. Substitution reaction means you can replace one atom by another atom. So this is called substitution. You can see here in the example of methane, we have replaced one of the hydrogen with one chlorine atom. So this is called methyl chloride and HCl form. Here they show addition. reaction because they are unsaturated. Here we can add one hydrogen here, so it forms, from ethene we can form ethane. Saturated hydrocarbons burns with blue flame. Unsaturated hydrocarbons burns with salty flame. So this is all about our today's lecture. Thanks for your time, dear student. See you tomorrow. Allah Hafiz.